Hello, so in this video we've got another question on small angle approximations, and this time it's a bit of a bigger question. We've got a fair few parts here. So if we start off at the very beginning, part A says to find cosine of 0.326 radians, correct to 6 decimal places. Now this one, nothing really complicated to it. You literally take your calculator and just plug that straight in. So make sure it's on radians. That's normally the biggest mistake, to have your calculator on degrees. And do cosine of 0.326. And we should get our answer. And that wants to be 6 decimal places. So that'd be 0.947331. Yeah, so hopefully that made sense and you could do that. Then the next bit here, we have B, which says use the approximation for cos theta to find an approximate value for cos of 0.326 radians. So this one that we found just now, that should have been the exact value. We're actually using the cos function. But when we use the approximation, we're using this thing here. Remember, we know that cos theta approximates to 1 minus theta squared over 2. So all we do is plug that in. So 1 minus, and then for theta, we put in the 0.326. And that must be squared and divided by 2. Again, you're going to have to put that into calculator. And if we do that one, that should give us 0.946862. So a little bit different to this, because they are pretty similar. So pretty good approximation. Yeah, it's very, very similar. And remember, that works because our theta value is very small. It only works if theta is small. Okay, so part C says calculate the percentage error in your approximation. So percentage error is a really important concept and mainly comes up in this topic here. So percentage error, I've just written the formula out for us here. To find it, you basically want to find the difference between the true value and your approximate value, which you can do by finding doing the approximate value minus the exact, and so that's the difference between the two. And then you divide that by the exact correct value, and times it by 100 to turn it into a percentage. So in our case, the approximate value was this one here. Yeah, the 0.946862. Whereas the exact value was the first one we found, 0.94, that's meant to be a 4, 7331. And we put all of that over the exact, so over 0.947331, and times it all by 100 to put it into a percentage. And if you plug all of that into your calculator, should end up giving you minus 0.0473. Let me just check how many decimal places that is. So it doesn't say how many decimal places the percentage error needs to be. So I would just do 3 significant figures, like that. That's it. So what that's really saying is that our approximate value was 0.0473% lower, because of a negative sign, than the exact value. So it's out by that much. And that's it. Then for part D, it says calculate the percentage error in the approximation for cos of 0.8 radians. So this is now kind of a completely different question. So parts A, B, and C were all related to this cos value. But now we're trying to do the same thing as we did in part C, but for cos of 0.8 radians. So we're going to have to find the exact value, find the approximate value, and then plug them into the percentage error formula. We're going to do all of that for part D. So if we scroll down a bit, to find the percentage error for cosine of 0.8, we first of all need to find cosine of 0.8, which if we put that into our calculator, that gives us 0.6960707. And to be fair, you can keep it to as many decimal places as you can, but that's fine to write it like that. Then for this one here, plug that into calculator. So we just do This is using the cos formula again, 1 minus theta squared over 2. And that gives us 0.68. So then as the percentage error, we do the approximate value of 0.68 minus the exact value of 0.6967 divided by the exact value of 0.696707. And if you do that in the calculator, it's best if you just use the answer key rather than actually writing out to 6 decimal places. And we have 0.68 minus answer divided by answer and times the whole thing by 100. And that now is minus 2.39 or 0.40 actually. Yeah, so negative 2.40%. That's not very neat, is it, this 4? I just changed that. So that's now the percentage error. If we look at the last question then, explain the difference between your answers to part C and part D, what they're really asking about is the difference between this percentage error and this percentage error. And the main thing to notice here is that this is much bigger. Yeah, this one was like nearly 2.5% out, which is fairly big. Whereas this was way less than 1%. So this was like a much better approximation than this one. And we've got to think kind of why. And the main point is that this is not really a very small angle. Yeah, in the first case, 0.326, that's a pretty small value. 0.8 though is much bigger. Remember, as soon as you get past 0.5 or 0.6, it gets much less accurate to be doing this approximation. So that's always right. The larger the value of theta, the less accurate the approximation is. And 0.8 is much larger than 0.326, so this is going to give a less good or less accurate approximation. And that's it. So I hope that all made sense. If you have any questions about any of that or anything you don't get at all, let us know down in the FAQ. And otherwise, have a go at some questions to consolidate it all, and we'll see you in the next video. Thanks.